From the dawn of time we have looked beyond, wondering, dreaming of what lay outside our grasp. We grew across vast landscapes and took one small step, first to the moon, then we looked to Mars, we built a space station, but still we wondered what lay beyond. Now it's time for a courageous group of men and women, led by the best of the best that mankind has to offer. We now seek to take that one small step and turn it into one giant leap. We are ready to take on new challenges as our quest to the outer reaches of space continues. What answers will we find on our quest? Our quest to discover the galaxy.
Hi everyone, and welcome to this week's episode of Discover the Galaxy. I'm your host, Jason Ross. On this week's episode, we're going to look particularly at the weather. You know, there are a number of satellites that circle around our planet that give us great information on the melting of the ice caps, the impact of tornadoes and fire, and what's happening to the planet generally from the last 100 years through to today. We're going to take a look particularly at the Aqua satellite that looks at water obviously, the Terra satellite that looks at land, and believe it or not, the Jason satellite that takes a look at the rising sea temperatures as well as the height of the seawater itself. So without any further ado, let's get the program underway, look at the weather patterns here on Earth and see what we can learn that helps us discover the galaxy.
NASA satellites constantly circle the globe, using a range of ingenious instruments to monitor the Earth's weather, climate, and biosphere. But just like our eyes, there's one thing many of them can't do: see through clouds. Luckily, there are a few instruments that are here to help.
The AMSR-E instrument is a microwave radiometer. That's sort of like a radar in reverse. Has a big dish, kind of like one of those big TV dishes that you see out in people's yards. It sits up on the Aqua satellite, kind of like a hood ornament, and it measures all kinds of important things that we need to know to understand the water cycle. You know, where the water goes, from evaporation in the ocean to rainfall over ocean and land and sea ice and snow cover and all of these different things we can measure with this instrument. And they're all important to understand the Earth system, the climate system, to see how everything interacts with everything else. One of the things that we can measure with AMSR-E is sea ice cover in the Arctic and around the Antarctic. And one of the cool things you can do with this imagery that we have in the microwave, and we're looking through clouds at the sea ice, is since we cover the Arctic and Antarctic every day, day after day after day after day, and sea ice changes kind of slowly as it melts or as it freezes and as the wind pushes it around, you can make an animation of this, which ends up showing you very nicely how sea ice evolves during, let's say, the freeze portion of the winter, or during the summer melt season, and how the ice flows as the wind pushes it down past Greenland, in between Greenland and Canada. It shows us dynamically what's happening, and what's really cool is that with an instrument like AMSR-E, you can see all this even if there are clouds in the way.
Sunlight issue becomes big because in the wintertime there are months without sunlight, and so for all those months where a visible satellite instrument would not allow you to get information because you didn't have sunlight, the AMSR-E microwave instrument does allow you to get the information. So with the AMSR, we can get information daytime or nighttime, and cloudy or not cloudy, about the Earth's surface.
One of the products from AMSR-E that's being used more and more are these sea surface temperatures that we can measure right through clouds, because the hurricane centers around the world using sea surface temperatures from AMSR-E to see how warm the water is out ahead of the hurricane, but then also as the hurricane goes by, it leaves behind a cold wake of water, which if there's a hurricane that's coming behind it, that will tend to kill the hurricane coming behind it. And the hurricane forecasters are excited about the information they have that they didn't have before.
AMSR-E data also help us understand our changing climate.
AMSR's contribution to the science of climate change has been, for example, a long-term record of global sea surface temperatures in all weather conditions through clouds. So we have this very important long-term data set showing how much is the Earth warming. What happens when the Earth cools during a La Nina event? We can ask the question, what caused the cooling? How did the cooling affect cloudiness? These are things that we can do with this long period of data that we're now getting from AMSR-E.
Of all of the instruments in NASA's Earth observing system, MODIS has proven to be one of the most versatile, producing both groundbreaking science and compelling images. The moderate resolution imaging spectroradiometer on both the Aqua and Terra satellites has changed the way we look at our atmosphere, oceans, and land.
MODIS increased the wavelength range, covered more physical properties of the environment that it could monitor. It measured them down as small as 250 meters, size of a couple football fields in size, and had many more spectral bands to study more aspects of the ocean biology, of the land, fires, and it was a very technological advance in capabilities. And for a long time in the EOS community, it was referred to as the quintessential instrument of EOS because it did more things for more people, more disciplines than any other single instrument.
The study of clouds is, not surprisingly, incredibly important for understanding weather and climate. And until MODIS came along, it was commonly accepted that at any given time the Earth was about 50% covered by clouds. But data from the instrument showed that cloud cover was actually closer to 70%. MODIS can also measure the temperature and height of clouds and differentiate between clouds composed of liquid water and those made of ice. MODIS also monitors the world's oceans, measuring sea surface temperature, ocean color and clarity, and the basis of the marine food chain, phytoplankton.
MODIS has done a very good job of getting this biological signature, it's our chlorophyll A, which follows phytoplankton and ocean currents, and you can see the seasonal variation due to El Nino and other things where the biological productivity of the ocean. This is important because this biological photosynthesis takes carbon dioxide out, produces oxygen as part of photosynthesis, and so it is a sink for carbon that we, man, put in the atmosphere.
MODIS also looks at the land, monitoring fires, land use change, and various measures of the Earth's plant life.
So it's been used for a long time to monitor the growth of vegetation, the seasonal cycle, and how that changes year to year, whether it's due to droughts associated with El Nino or spread of the Sahara. But it's a very good index to monitor.
The versatility of MODIS, as it measures land, sea, and air, contributes to the wealth of information being revealed by the Aqua mission.
Hi everyone and welcome back. In this next section of Discover the Galaxy, we're going to take a look at the JASON, well-named, satellite that looks at the surface temperatures of the water as well as the rising sea levels. It's going to show us the impact that various factors in the environment, including global warming, are having on our oceans as well as the marine life contained within them. So let's take a look at what's happening to our waters through the Aqua and the Terra satellites and how we're going to have to change our ways if we're going to improve things in the future. If it's not too late, that is. Anyway, let's have a look, shall we?
Earth is the water planet. Although 40% of Earth's population lives within or near coastal regions, the ocean impacts people everywhere. Most of Earth's water is stored in the ocean, a driving force for weather and climate. The Earth's surface is warmed unevenly by the sun. Heat, a form of energy, helps drive ocean and atmospheric circulation. The ocean absorbs and stores more heat than the atmosphere. Both the atmosphere and ocean move heat. The atmosphere does this quickly, the ocean slowly. At the ocean's surface, winds drive currents. Multiple forces keep the global ocean conveyor belt, or thermohaline circulation, in perpetual motion. Below the surface, deeper currents are driven by differences in density. Mixing and upwelling in the ocean, transporting nutrient-rich waters to the ocean's surface. Nutrients sustain biological productivity in the ocean. Extreme variations in sea surface height and sea surface temperature affect ocean and atmospheric circulation. El Niño and La Niña occur when changing wind patterns displace warm and cool water in the equatorial Pacific. Both have global impacts. During either of these events, the replacement of cold water by warm water leads to air temperature swings and changes in humidity. This alters weather patterns by steering storms and rainfall to new locations. Shifts in rainfall affect plant growth and areas impacted by drought. When heat is exchanged between the ocean surface to the atmosphere, it influences climate. For example, heat and moisture carried by the Gulf Stream northward bring warmer temperatures and a moderate climate to Europe. An eddy is a circular moving body of water that spins off a main current. Eddies play a major role transporting heat and nutrients. Thunderstorms are a frequent occurrence in the tropics. Some of these may become organized into large rotating systems with strong winds growing into tropical storms or hurricanes. Tropical ocean basins like the Caribbean and the Gulf of Mexico retain substantial heat, making these regions favorable for rapid storm intensification. By extracting large amounts of heat from the ocean, storms can become massive and destructive hurricanes. A driving force for weather and climate. The ocean is essential to life on Earth. It is the primary storehouse of Earth's water. Without the ocean, our planet would be uninhabitable.
Hi and welcome back to Discover the Galaxy, our special weather episode. In this last section, we're going to take a look at the Aqua and Terra satellites that look at the water and land respectively. We've looked at how the polar ice caps are melting. Did you know that Antarctica was originally a landmass that was full of animals, including dinosaurs? By contrast, the North Pole is just completely water frozen over with an icy surface. As these melt, it has impacts on rising sea temperatures as well as sea levels, and the impact on things like El Nino and El Niño, the wind patterns across the Earth. So let's take a look at what impact the Aqua and the Terra satellites can show us, and what we've come to learn about the future implications for weather management here on planet Earth. Let's take a look, shall we?
What safeguards our solar system is our star. The Sun provides a shield stretching beyond the last planet in its orbit, a force field that deflects these cosmic rays. But these solar winds can be dangerous too, especially during outbursts called coronal mass ejections. Want a vision of Earth gone wrong? Just look at what solar storms do to our sister planet, Venus. They strip away lighter elements in its upper atmosphere, hydrogen, oxygen, and the molecule they form, water. What's left is a witch's brew of noxious chemicals, including thick, sulfurous clouds. How has Earth avoided the grim fate of Venus? We can see the answer as the solar storm approaches Earth. Our planet has a protective shield all its own, a powerful magnetic field generated deep within its core. In fact, that's just our first line of defense. Much of the solar energy that gets through is reflected back to space by clouds, ice, and snow. The energy that Earth absorbs is just enough to power a remarkable planetary engine, the climate. It's set in motion by the unevenness of solar heating, due in part to the cycles of day and night, and the seasons that cause warm, tropical winds to blow toward the poles, and cold polar air toward the equator. Wind currents drive surface ocean currents. This computer simulation shows the Gulf Stream winding its way along the coast of North America. This great ocean river carries enough heat energy to power the industrial world 100 times over. It breaks down in massive whirlpools that spread warm tropical waters over northern seas. Below the surface, they mix with cold, deep currents that swirl around undersea ledges and mountains. Earth's climate engine has countless moving parts, tides and terrain, crosswinds and currents, all working to equalize temperatures around the globe.
Does the scientific community feel that global warming is decreasing or increasing? Yeah, you know, like a lot of people ask me, like, has there been a pause in global warming because, like, temperatures aren't increasing as fast as they were a decade ago? And I always say, you know, pause are for kittens and puppies because global warming is definitely still increasing. We're still getting more heat trapped into the oceans. The oceans are sucking it up. And sea level's still rising. Look at the sea level record for the last decade. It's going up like gangbusters, hasn't slowed down. So is there a pause in global warming? No, there's not really a pause in global warming. Sometimes there's natural fluctuations and we warm up a little faster in one decade and a little slower in another decade. But global warming, human-caused climate change, that's definitely going right on up in there. We haven't slowed down at all.
Some parts of the world burn every year. Australia is one of those places. The fires in central Australia are grassland fires that burn in largely unpopulated areas. The areas in the north are comprised of eucalyptus woodland and savanna fires. Agricultural fires dominate Asia and Southeast Asia. Crop cultivation fires in China, Thailand, and the Punjab region of India can be seen here. Catastrophic forest fires in Russia, where it takes a long time for the vegetation to recover, can also be seen. Africa really is the fire continent. As healthy green vegetation dries, these areas are consumed by sweeping waves of fire that move from north to south and south to north each season. The fires in Africa are primarily grassland fires, but there are also management fires associated with agriculture and maintenance. In South America, you see pastoral maintenance fires in the Amazon basin and fires that are used to clear the tropical rainforest for agriculture and grazing. In the United States, you can see fires in the southeast associated with forestry and agriculture. The recent fires in Texas and wildfires in the west are also seen.
Unfortunately, that's all the time we have on this special edition that looked at the weather here on Discover the Galaxy. I hope you've enjoyed looking at the history of global warming on our planet, the impact it's had on our melting of the ice caps, rising sea temperatures, rising sea levels, and then the general rise in temperature. Is it man-made? Is it natural? I'll leave that for you to decide along with our scientists and some of our skeptical friends. But at the end of the day, we know that the temperatures are rising and there's implications for all of us in terms of the way we manage the planet. Having said that, I hope more importantly that you've enjoyed watching the program. Hopefully you've learned a little and you've enjoyed seeing it all. Until next week, I'm Jason Ross, and together let's learn as much as we can, not just about our planet, but the solar system, and even larger than that again, let's discover the galaxy. See you next week, everyone. Bye for now.